Here, I have 4 official size table tennis balls. Each one has a diameter of 4 centimeters. And of course, the radius would be 2 centimeters because half the diameter is the radius. In other words, the distance from the center of the ball to any point on the surface is 2 centimeters. Now I'm going to put these 3 on the floor and put the other one on top of the 3. So all of the 4 balls are in contact with each other. And my question is, what is the height of this entire figure that I just made? How tall is it measured from the floor? Someone might say, this is easy. It's just 8 centimeters, 4 plus 4, because the diameter of each ball is 4 centimeters. Well, that's gonna be true when one ball is on top of another ball. But since this ball is in the middle of the 3 in the bottom, it sinked down a little bit. So the height would be less than 8 centimeters. Then how tall is this figure? What will be the actual height? Let's try to figure it out. One of the strategies of approaching this type of problem is to visualize. Try to visualize something using what you know already. A perfectly round ball can be called a sphere, and every sphere has a center. So let's visualize the centers of these 4 spheres. This is the center of the sphere on the top, and these are the centers of the spheres on the bottom. Now, what can we do with the centers of the spheres? This time we can visualize the lines connecting the centers. By connecting the centers, what we have is a tetrahedral, which is a pyramid that has 4 equilateral triangles as its faces. And the length of each side of this pyramid is 4 centimeters because it's composed of the radius of each sphere. Since the radius of each of the sphere was 2 centimeters, 2 plus 2 makes 4 centimeters. Now, if I can just find the height of this pyramid, which is the distance from the vertex of the pyramid to the center of the base, I can just add 2 on the top and another 2 on the bottom to the height that I find. Because the distance from the vertex of the sphere to the top of this figure is the radius of this top sphere, which is 2. And the base of this pyramid is as high as the radius of the spheres on the bottom. So it's 2 centimeters apart from the floor. So we should focus on finding the height of this pyramid, and we can just add these values later to find the height of this entire figure. This is the pyramid that connects the centers of the spheres, and we need to find the height of this pyramid. And all we know at this point is that the length of each edge of this pyramid is 4. But how does that help us to find the height? And like I said a couple of times already, we need to visualize something. And this time I'm going to visualize a right triangle that has H as one of the sides. And this right triangle gives connection to this right triangle, for which I know at least one side. And we're going to use 2 important ideas about right triangles. One of them is Pythagorean theorem, which states that square of the hypotenuse equals sum of the squares of the legs. And the other idea is that when you have a right triangle with 30 degrees and 60 degrees, the ratio of the sides is 1 to root 3, which is roughly 1.7. And the hypotenuse is twice the shorter leg. Now, since each face of the pyramid is equilateral triangle, we know that this angle will be 60 degrees. So using this ratio, we know this is 2, which is half of 4 anyway. And using this ratio, we can find that this is 2 root 3. And finally, we're going to visualize one more thing. we're going to draw a line from this point to the center of the base. And that makes a right triangle again. And since this is half of 60, it will be 30 degrees. And using this ratio again, we can find this side right here. And instead of multiplying by root 3, we have to divide by root 3. Because we're trying to find the smaller leg using the bigger leg. So this length is 2 divided by root 3. Since we know these two sides of the green right triangle, we can use the Pythagorean theorem and find this height. Square root of hypotenuse 2 root 3 will equal the sum of the squares of the legs. So h squared plus 2 over root 3 squared. And since both of these are squared, it will be 4 times 3 equal h squared. Again, both the numerator and denominator are squared. It will be 4 over 3. If you subtract this from both sides, 12 minus 4 over 3 will equal h squared. And if I rewrite this using common denominator 3, it's 36 over 3. And subtract 4 over 3, that's 32 over 3, which is h squared. Finally, I should root both sides to get rid of this squared. And I root the left side as well. So h equals root 32 over root 3. If I rationalize the denominator by multiplying root 3, that's root 96 over 3. I need more room, so let me take that up here. So root 96 over 3. If I simplify this a little bit, since 96 is 16 times 6, I could take this 16 out and write it as 4 root 6 over 3. And that's the best looking answer for the height of the pyramid. But this is the height of the pyramid alone. So to find the height of the entire figure, we need to add the radius on the top and on the bottom. So the final answer will be 4 root 6 over 3 plus 4. Wow, it took some time to find our answer. But we did it. And to get the better grasp of how tall this is, it's roughly 7.3 in decimal, which is obviously less than 8. Thank you for watching. I'll see you next time.